Right. So now what we're going to do is we'll go ahead and take kind of a little bit of a sidestep, and we're going to talk about analyzing mixed costs. So let me go ahead and share. So Appendix 5A, analyzing mixed costs. So first of all, what is a mixed cost? An example of a mixed cost that we're probably familiar with would be our utility bill, like our PG&E or MID or TID or whoever you get your electricity from. The other thing I know around where I live, we have a water district where we get our water from. So it's not the city, it's not whatever, but a lot of cities probably do the same thing. They recently started that a few months ago where the same kind of thing, where there's a fixed portion and then there's a variable portion. So let's look at this. There's a fixed portion of a utility bill. That part is going to remain constant regardless of how much usage there is. So if it's electricity, electricity is measured in kilowatt hours. If it's water, it's based on gallons, but they don't base it on gallons. They base it on cubic feet of water. And so the fixed cost is the minimum cost that is incurred to have that service ready and available for use. So even if you use absolutely no electricity or no water, you're going to pay whatever the fixed cost is. Now, the variable portion is going to vary based upon the consumption of whatever it is. So if it's electricity, it would be kilowatt hours. If it's water, it would be cubic feet of water. And that changes. So for example, if there's one month that it's in the summer and it's really, really hot and we have 110-degree days all month, which that wouldn't happen, but it's really hot, you're having to run your AC a lot, obviously, then the variable portion of that's going to be very high. But the fixed portion of that is going to stay the same regardless. Or thinking about the water, this next month, we were gone a whole week. Well, we were gone for 3 days. And so we weren't obviously using water during that time. I mean, they might have used a little bit of water. They had to fill up the dog's water dish or whatever. We had the in-laws over here that they came several times and looked after the animals, let them out and fed them and watered them and cleaned up after them. But the variable portion of that might be a little bit less because we were gone. There were three days that we didn't use water. So that may be less, but a little bit less for that month. But the fixed cost is going to be the same regardless. But how is this important for a business application? So an account analyst and an engineering approach. So an account analysis is where an account is classified as variable or fixed based on the analyst's prior knowledge of how cost in that account occurs. And so, for example, direct materials would be classified as variable because it's going to vary based upon how much is used. Building lease would be a fixed cost because of the nature of how that account behaves. It's a fixed. A lease is going to be based usually on the square footage, and that's not going to change. Now, an engineering approach involves a detailed analysis of what cost behavior should be based on an industrial engineer's evaluation of production methods that are used, material specifications, labor requirements, equipment usage, production efficiency, power consumption, and so forth. So if we look here, we can set up what's called a scatter plot. And so background data relating to the hours of maintenance work and the total maintenance costs for the past 6 months are shown here. So we see here, the different months, January through June, And then we see here the number of hours that were used, and then also what the total maintenance cost was. And so we can put that on a graph. We can say the number of hours and then what the total maintenance cost was. And we see that the total maintenance cost, which is Y, is plotted on the vertical Y-axis. Cost is known as a dependent variable because the amount of cost incurred during a period depends on the level of activity for the period. The activity, or X, which in this case is the number of hours of maintenance, is plotted on the horizontal axis. Activity for this would be known as an independent variable because it is what causes the variation in the costs. Now, after plotting the data, examine the points in the scatter graph to see if the points lie more or less within a straight line that slopes upward and to the right. Linear cost behavior exists whenever a straight line is a relative approximation of the relation between cost and activity. If the scatter plot does not depict linear cost behavior, then it makes no sense to proceed any further at analyzing the data. In this example, the dots are linear, so we can proceed with the high-low method. So in this, we can see if we were to draw a line, we could almost draw a line, and it follows that. So now we'll go ahead and do the high-low method. So an equation that we can use to express the relationship between mixed cost and the level of activity. This equation can be used to calculate what the total mixed cost would be for any level of activity. And that equation is is y equals a plus bx. Y is the total mixed cost. A is the total fixed cost. B is the variable cost per unit of activity, and X is the level of activity. Remember, when you have two letters, two variables right next to each other like that, with no symbol in between, that means to multiply. So we would multiply B with the variable cost with the level of activity, which is X. And so here is an example. So for example, if your fixed monthly utility charge is $40 and your variable cost is 3 cents per kilowatt hour, then your monthly activity level is 2,000 kilowatt hours. Then this equation would be used to calculate your total utility cost to be $100. So again, we have the fixed cost, and then we have, which is 40, regardless of what the level of activity is. If you use no electricity, you went away for a month, you would still pay the $40. And then we have 3 cents times the number of kilowatt hours. So we come out then that the bill would be $100. So we can use the high-low method. So the high-low method then is used in order to analyze mixed cost if a scatter graph plot reveals a linear relationship between the X and Y variables. And so we'll look at our data that we looked at previous. The first step is to choose the data points pertaining to the highest and lowest activity. And we see here that the highest activity was 850 and our lowest activity was 450. Notice this method relies on two data points in order to estimate the fixed and variable portions of the mixed cost. And so then the second step is to determine the total cost associated with the 2 points. And so high would be 9,800 and low would be 7,400. And so in order to do that, because you have and we'll look at how they calculated that. Actually, they went ahead and gave you that amount. Just know that the high and low points are identified by the level of activity and not the level of cost. So we're looking just solely at the number of hours in this case. So then our third step is to calculate the change in cost between the two data points, which is 2,400. So if we take the high amount, which is 9,800, subtract from that the low amount, which is 7,400, we get the change is 2,400. And then we can divide that by the change in the activity level between the 2 points. So in this case, the high amount of maintenance is 850 and the low amount of maintenance is 450. And so the difference is 400. And so if we take that, we're going to take the total fixed cost, which is 9,800, and then we'll subtract $6 an hour times the 850. Or we're trying to find out the fixed cost. So we have the total cost minus the variable cost, which is $6 times 850, and then we're going to take the 9,800 minus the 5,100 in order to get 4,700, which would be the residual represents the estimate of the total fixed cost, which is 4,700. So we would take the total cost at either activity level, in this case 9,800, deduct the variable cost component of 5,100, and that gives us the total fixed cost. So the variable cost component 5,100 is determined by multiplying the level of activity, which is 850 units, by the variable cost, which is $6. And I believe they told us that they figured that out here. So 2,400 divided by the 400, which is the amount of change in this, is $6. That's how they calculated that. So now the fifth step then is to construct an equation that can be used to estimate the total cost of at any activity level. And so for that, we're going to do y equals 4,700 times $6 or plus $6 x. So we can do a quick check on that. So in order to calculate, we can say that sales salaries and commissions are $10,000 when 80,000 units are sold and 14,000 when 120,000 units are sold. Using the high-low method, what is the variable portion of sales salaries and commission? And so it would be 10 cents per unit because we can take 4,000, which is the difference between the two, divided by 40,000 units, which is the difference in number of units. So that comes out to 10 cents per unit. And then also we want to know what the fixed portion of it is. And so in order to calculate that, it's going to be 2,000 because we're going to take the total cost, which is 14,000 at the highest level. And then we want to know what the total fixed cost is. So at 10 cents times 120 units, we'll multiply that out. So 14,000 minus 12,000 means the total fixed cost was 2,000. Then we'll take a look at the least squares regression method. Now, unlike the high-low method, the least squares regression method uses all of the data to separate a mixed cost into the fixed and variable portion components. The basic goal of this method is to fit a square line to the data that minimizes the sum of the squared errors. The regression errors are the deviations from the plotted points to the regression line and are measured vertically on the graph. The formulas that are used for least square regression are complex. Fortunately, Excel can be used to estimate the intercept or the fixed cost and slope, which would be the variable cost per unit, that minimize the sum of squared errors. So Excel can provide a statistic called the R2, which is a measurement of the goodness of fit. And the R2 tells us the percentage of the variation in the dependent variable or cost that is explained by variation in the independent variable or the activity. It varies from 0 to 100%. The higher the percentage, the better. And then the least squares regression method uses all of the data and generates a regression line of the form of y equals bx plus a, which is fitted to the data. The intercept, which is a, represents the estimated fixed cost. The slope, which is b, represents the estimated variable cost per unit of activity. The R2 indicates that percentage of the variation in cost that is explained by the variation in the activity. And then the high-low and the least square regression methods provide different estimates of the fixed and variable cost components of a mixed cost. This is to be expected because each method uses differing amounts of the data points to provide estimates. Least squared regression provides the most accurate estimate because it utilizes all of the data points.